Hello, and welcome to our second video lecture of the year. This is section 1.2, the classification of data. And like the first lecture, this is going to be pretty short and sweet. Mainly just, I'm going to introduce 6 more terms, give some examples about what types of data that we're looking at. Okay. Data is going to be classified into 2 types, qualitative data and quantitative data. And your book gives a slightly different definition, but I'm just going to give you a definition that's very simple and that kind of works. Okay, let me just do what define quantitative data first. Quantitative data is just numerical measurements or counts. And qualitative data is everything else. Okay, basically, it's not numerical measurements. Or counts. Okay. All right. So it's pretty simple. Ask yourself: is this a numerical measurement or count? If the answer is yes, it's quantitative data. If not, it's qualitative data. Okay, so basically, when you're measuring like something like time or weight or cost or something like that, those are all always quantitative data. So a way to think about it is this is N. The N here stands for numerical or number, so you can think about it just N for numerical measurements or counts. Okay. So if we go to our examples here, weights, that would certainly be quantitative. Okay, hair colors of classmates, hair colors, they're certainly can't be represented by numbers, right? So this would be qualitative. Okay, student ID numbers. Now they are, even though they involve numbers, they are certainly not measurements or counts. So this would be qualitative. The wait times at a DMV, those are certainly measurements, so this would be quantitative. Temperatures, those are measurements, they're quantitative. Okay. The top 10 ranked business schools in U.S., well, technically they're not really measurements, they're rankings, right? So this would be qualitative, because now, it might be that they might use some combined score to rank them, but those scores would be quantitative, but they're just the rankings. This would be an example of qualitative data. Years that an American League team has won the World Series, right? Well, that would be that. I guess you could consider that both, right? Anyway, we could we could say that's quantitative, because you're phone numbers are not measurements, so that's definitely qualitative. The departure times, those are measurements of time, right? So that would be qualitative, or quantitative rather. And the number of times a temperature were above normal in 13 cities, well, those are counts, so that's quantitative. Okay. So it's pretty straightforward, except for maybe one of these. It was pretty straightforward. All right. So in addition to that, knowing that, we have levels of measurement that we need to worry about. Actually, we don't have to worry about them. We won't be doing too much with them. But you should be aware that there's nominal forms. So nominal means names. So nominal data, or a nominal measurement, this applies to names, labels, qualities. Okay, things that just don't have any numerical value at all. And because of that, this applies to qualitative only. All right. Ordinal. Ordinal, well, as the name indicates, this is data that can be ordered. Okay. And this could be considered both qualitative or quantitative. The main thing is, even though it's ordered, it can't be. We're not really going to pay attention. Maybe there are numbers involved, but the differences between the numbers and the ratios of the numbers, they don't matter. And neither do zeros if there are any zeros involved, right? Matter that maybe you can subtract them, but or divide them, but they won't mean anything. Okay, and the zero doesn't really indicate the absence of anything. Okay, then there is interval. Okay, interval data or order level of measurement. This can be ordered, and differences matter. But ratios and zeros do not. Okay. And this is quantitative only. Okay. And the standard example of an interval level of measurement would be zero. Would be temperatures. Okay, because obviously. A temperature is like it's certainly a measurement, and it can be ordered, and differences matter. Obviously, like 100 degrees means something. If 100 degrees is warmer than 85 degrees, right? So differences matter. However, ratios do not. If the temperature is 2 degrees outside, that doesn't mean it's twice as hot as 1 degree outside, right? So ratios don't matter. If it's 0 degrees, it doesn't really indicate the absence of heat, right? That would be absolute zero, okay? Using kelvins, but that's something else. So temperature, usually intervals are the typical example of that is our temperatures, and then the ratio. This is everything matters, so it can be ordered. And differences, ratios, and zeros matter. Okay, so ratio, an example of ratio level of measurement would be, measuring your age, height, weight, the cost of something, right? Usually, that's what you usually think of when you think of data. Okay. And then we also have an example of term here, an inherent zero. Okay, this just means indicates the absence of something. So the zero means the absence of something. So $0, 0 inches, that indicates the absence of, or 0 grams of sugar, let's say, that indicates the absence of something. 0 degrees would not. Or if you have a 0 on someone's jersey, that doesn't indicate the absence of anything, right? Okay. So if we go back to our examples here, weights. Those are clearly an example of ratio. Okay, we can talk about one dog being twice as heavier than the other, because the hair colors of classmates, we can't really. That's qualitative, so it's either going to be nominal or ordinal, and it really doesn't make any sense to order the colors of hair. So this would be nominal. Okay. Likewise, student ID numbers. They can be ordered, but their order really doesn't mean anything, so this would be nominal as well. Okay, even though there are technically numbers, we're using the numbers as just another way to ID people, like names. The wait times, that would clearly, that's clearly a ratio level of measurement. We already said that temperatures, that would be an interval level of measurement. The top 10 ranked business schools, that would be qualitative, so it's either going to be nominal or ordinal, and because order matters, in this case, this would be ordinal. Okay. The years that an American League team has won the World Series, well, those are numerical counts, right? There's a consequence of counts. Differences do matter, right? If you win a team, if a team won in 2020, or if a team like my Indians team, they haven't won since 1948, so the difference does definitely matter in those cases. So actually, this should, not only is this quantitative, but this would be an example of interval. Ratios, a ratio, of course, really wouldn't mean anything. If we took 2020 and divided by 1948, it wouldn't really mean anything. Phone numbers, okay, phone numbers, that would be, those are nominal. The order doesn't mean anything. The departure times at airports, these are times. The differences matter. I would say the ratios don't necessarily. If you take, 5 o'clock divided by 3:30, that doesn't really mean anything. So this would be another example of interval, I would say. And the number of times of temperatures were above normal. Okay, the number of times, that certainly the ratios matter, right? If something occurs twice as frequently as in one city than another, that means something. So this would be an example of ratio. Okay. So this is the general thing. Those 6 terms. We won't be using them that much in this class, but you should be aware of it. Okay. So that actually concludes chapter 1, and then in chapter 2 we're going to be discussing some stuff of more substance from a mathematical and statistical point of view. So I'll see you next time.